All right, guys, let's get to part 2 with Julian Finbow on pressure testing, refrigeration, and HVAC systems. Now, we get into a bit of a conversation about Nylog in the second half and how he's tested it in basically in a lab or bench test scenario. And now he's a believer and he uses it on a lot of different things when it comes to pressure testing, especially putting it on Schrader caps. And we get into this conversation and he explains why he tested it and what the outcomes are. So let's get back to this. Julian Finbow on pressure testing. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. Some people only wait 15 minutes for a pressure test. Some people wait longer. It really depends on the person and how much time they have and really how much patience they have and how much the customer is paying for the job, right? If the customer's cheaping you out on the job, you might only wait 15 minutes. But if it's a good paying job and you're taking your time, maybe you will wait an hour depending. But I do want to throw out the fact that the 400 PSI thing, there are VRF manufacturers that do heat pumps out there that want you to pressure test all the way to 600 because your operating pressure in heating mode is higher, right? So that's why. So if you apply that 1.25 to that higher operating pressure, you might get around the 600 mark. The other thing I want to throw in is I do 100% agree with you on pressure testing in increments. Mitsubishi even goes to the point in their manuals, and I can't remember all the PSI numbers, but I think the first one's like 50 PSI or something like that. So they want you to pressure test in like 5 to 6 different increments. Mitsubishi guys out there, you can correct me if I'm wrong, but it's somewhere in that range. It's like 50, then 100, then 200. Then they want you to go up in increments and watch each time. You don't need to do that. That's just a guideline to help you preserve your nitrogen and maybe find a leak with, 50 PSI in the system rather than 400 PSI in the system. It's just a way to conserve your nitrogen. So that resource, you're not throwing it all into the system and then losing it all. So going up in smaller increments, I 100% agree with.
Yeah, I have seen some write-ups where they want you to do 3 steps at least and stuff like that, but I tend to be against that. So my writing was just about my opinion, my experience, and
Your experiences, yeah.
and what you said about waiting shorter periods of time. I'm for that, right? Like I have the educational side of things where I list off all of the pertinent, correct information, but from working in the field a lot, if you have to get out of a place, like you literally, for whatever reason, if there's an emergency call, you have to leave and you don't have time to pressure test, you could forego it completely and just start a vacuum test. Like that could be a step 2, right? So shorter pressure test isn't the end of the world. You're going to see that on a decay test before you charge, right?
Yeah, no, for sure. There's a lot of industry professionals out there that say your vacuum decay is your best form of leak detection. And here is something that Jesse Stewart from NAVAC, he weighed in on this with me during a podcast about evacuation. He says both are important, and I agree with him. Both pressure test and evacuation are important. And he brought up this thing called like a flapper valve, I guess that he learned back in the day. And I guess you'd need like a really strong microscope to see this. But basically, if you've got a piece of silphos or something that is not fully intact, or you're not fully loaded up inside that joint, pressure testing, if you've got like a little flapper, pressure testing will reveal that flapper going outwards, and an evacuation test, if your flapper is going inwards, will reveal that one. I don't know if that's the right way to say it, but you see what I'm saying though? Let's say you have like this little flapper of silphos, right? And it only flaps out. Well, your evacuation will pull that flapper in and it won't reveal under a vacuum because you're sucking it in, right? It will only reveal on a pressure test because the flapper goes outwards type thing. I guess you'd have to really see that with a microscope to see if that's even a thing, but he was pretty adamant about that. So, and he knows what he's talking about. So I can imagine he's maybe encountered something like that in his career. But the thing with the evacuation, your pressure difference changes a lot quicker in an evacuation than it does with a pressure test if it's a very small leak, because you're introducing moisture into the system, and that micron gauge is very sensitive, and it's going to shoot up real quick, right? As compared to a system with 600 pounds of refrigerant or nitrogen in it leaking slowly, slowly, because that moisture in that system with the micron gauge is what's going to be very revealing to you. Do you agree with that, or do you have anything to add to that?
Oh, for sure. I mean, the flapper valve I didn't know about till right now, but it's amazing. But a complete specialist, like someone who works for NAVAC, can bring to you, right? Endless knowledge to learn. Um, for what you said about seeing the micron gauge shoot up, and albeit after you think you've done a successful pressure test, isn't that the most disheartening feeling of all time?
It is, and I don't want to get into a whole thing about evacuation, but your pressure could be rising for all kinds of reasons. It could just be more moisture in the system. It could be that your whole vacuum rig is leaking, or a
Yep.
portion of it's leaking.
Refrigerant in
So
the
it's
oil.
not always, yeah, a refrigerant in the oil, and that's what um, gets guys really caught up sometimes, is an old system that's like 20 years old and they're trying to get down to below 500 microns. Well, you might not ever, because there's so much refrigerant in that oil boiling out constantly. It could take you 2 days to get it all out, and you're changing a 5-ton compressor on a 5-ton rooftop. You're not going to stay there for that long to evacuate that system down, right? As long as you know there's no leaks in your system, you soap the joints on the compressor, on the dryer, you've got a new dryer in there, you pressure test, it passes, your evacuation gets down as low as you can get, right? And you start the thing up, and then hopefully the filter dryer gets the rest of anything that's in there. But that refrigerant boiling out of the oil isn't moisture. It's not a leak. It's just, it shows up as a contaminant on your micron gauge, but in fact, it might not really be. So you have to keep that in mind too.
Yeah, absolutely.
So any other points? You can spend a couple more minutes. Any other points to throw in about pressure testing on your side?
Well, I would just think about components, right? Like I mentioned flare nuts. I think you covered a lot of good content in the past couple of years that I've checked out about flares, how to make a proper flare, and you know, Navac makes a great electric tool for doing that. Torquing your flares is becoming common practice. It's very good practice. There's other ways to do it too, like whatever flaring tool you're using. One thing that I only became, I guess, conscious of in the past maybe year and a half. There's a whole debate on if you ream or don't ream your flares, right? I'm sure you maybe heard part of that, Gary, or maybe I saw it under the microscope from teaching trade school.
I always ream them, but I've heard people say they don't ream them. So you give me your input on that. I'd like to hear it.
All right, so if you're talking about making a flare and reaming versus not reaming, I would say the benefit to reaming is that you get a more uniform piece of pipe, and when you flare it, in theory, it should flare in a more uniform manner, and it should be, um, less eccentric. It should be almost perfect. One thing that can happen when you use a reamer, a pencil style reamer. So to be clear, that's the style where there's basically kind of like it looks like a jail tool. It goes inside the pipe and you spin it around, right? That can actually scratch the inside surface of the pipe while you're reaming it. And then when you make your flare, the inside of the flare can have scratch marks on it, and that will leak.
Not if you put Nylog on it.
It'll it'll clear that up more than likely, right?
No, I get what you're saying. The reason I've reamed them, Julian, is because I find that if when you cut it, your cutters leave a lip, right? Right? And when I find when I ream it, sometimes that lip doesn't sort itself out. The lip is still kind of there.
Yes.
So that's why I've always reamed it. So when I ream it out, I've got a flat piece of copper to put on the other end of that, to put on the brass side of the flare before I tighten it up. That's why I've always done it that way. And honestly, I've made posts about it in the past. If your flare is 45 degrees, you use Nylog and you torque it within the range that, because the manuals have ranges. It's not just, or at least the manuals I've been reading lately have ranges. It's not just one torque and it's that torque. It's ranges. So I try to go in the mid range, really. I set my torque wrench to the middle of that range. Some Nylog on the seat where it seats, not on the threads, on the seat where it seats, and it fills in any imperfections, any gaps or anything like that. And then you torque it. And I've never had a flare leak when I do those three things, ever.
That's great.
Right? I've had a flare leak when I don't use it. I was on a VRF job a year and a half ago, and the 1/4-inch lines that I was flaring, I didn't have my torque wrench on me. I over-tightened 2 of them when I went to pressure test. They were leaking, and I pulled the flare off, and I had destroyed it. I went way too tight, right? And you think that you're going, "Oh, yeah, I'm gonna go and, yeah, that feels good. I'm gonna go a
Calibrated
little bit
hand.
more." A calibrated hand, but when you're dealing with small pipe like 1/4 inch, you have to be very careful. So I cut them out, reflared them, grabbed my torque wrench, and torqued them to spec, repressure tested, and not a problem. That system's been up and running now for about a year and a half, and I haven't had a call back on leaks or anything like that. So it just goes to show you that when you do it properly and the way you're supposed to do it, you avoid all kinds of potential chaos happening down the road.
Yeah, and what I really like from what you said is that you go to the mid-range with the torque recommendation. The simplest way for me to think about that is that's the reason people say 2.5 to 3 rotations when you're threading a fitting into a piece of pipe, because if it leaks, you want to have somewhere to go. That's the whole principle of not over-tightening anything. If it leaks, you have somewhere to go. If you go full retard right away and there's a leak, your options are very limited. You'd have to over-tighten it or disassemble it, right? So, the side of not reaming, so the school of thought on that is that you have more material left over for your flare to be made out of. And the second school of thought on that is that it is less likely for your flare to split. And I would say that if you have a consistent process like the one you explained, splitting flares is almost a non-factor unless there's something that goes on bad with the cut or a coincidence, right? Where you cut that pipe, there's a defect, right? So I personally now I would ream, but I would not use a pencil style reamer. I would use like the V-shape one where you just kind of jut
The
into the
V-shaped
pipe.
one? Okay.
Yeah, that's
Yeah.
where I kind of came to. And other than that, the funny thing people don't think about, uh, whether you're gonna apply Nylog, which is great, or vacuum pump oil, which is another good thing to use as assistance for sealing. The flare actually is the gasket. So it's kind of weird, but you have a flare nut and you tighten it onto a piece of copper, and the piece of copper is going onto, let's say it's a flare on the compressor. That compressor component and the flare sandwich the gasket together, which is the flare nut.
Yeah. So I'm trying to think that in my head. So you're saying the flare nut is the gasket? Is that what you just said?
Sorry, I correct myself. The flare is the gasket. So the actual piece of
The
copper
flare,
between the flare nut and the compressor.
the piece of copper that's flared is the gasket.
Yes.
Yeah. Okay. No, that makes sense. It makes a hell of a lot of sense because I even put Nylog on gaskets too. I put it on the underside of a gasket. If I'm changing if I take the head off a compressor and I'm changing valves, I started doing this years ago because it actually helps the gasket stay in place too while you're mounting the head back on. So I understand what you're saying there. That the Nylog then the gasket, and that's the same approach you're doing when you're flaring. It's Nylog then the copper piece touching the brass. The other thing I do with a flare too, and flares leak a lot if they're not done properly. So I'm glad we're talking about this. The other thing I do with a flare is I hold the copper flare onto the brass body in place while I hand tighten the nut, right? Because if you don't do that, it might not sit center and sit true. So I always hold it true, the pipe and the flare. I hold it true to the brass piece, tighten it till it's hand tightened, and then I come back with the torque wrench afterwards.
Yeah, that's great. And what that makes me think of is you're helping it find its home. So as an alternate um, procedure to use besides torquing. So about 6, 8 years ago, when I was working at Carmichael Engineering, I had good success with this, and I brought it into when I was teaching at Mohawk College. It is that you tighten the flare nut in position after it's after you make it onto where it's going to live, like not max tightness, but let's say 80%. And then this is again calibrated hand mentality. Loosen it, like one rotation, and then tighten it to its final tightness. So that, in theory, allows the flare to kind of be pushed into where it's going to live forever. And then you give it a break, and then you come back to it and form it into the spot. And I had really good success with this. Yeah, I taught basic for a couple of years, and we did tons of these in the shop. And that was always my recommendation. And I mean, it was successful. But torquing
Interesting.
has become a lot more popular and easy to get the tools since that time.
Yeah. Yeah, for sure. Cool. So anything else you want to throw in as far as pressure testing before we head out, Julian?
Another probably thing just to be aware of is Schrader valves, right? So I have more beef with Schrader valves than I do with flares. So there's alternatives to both of them.
I've had a beef. I just, before you go on, I've had a beef for years with Schrader valves.
Yeah.
Because I find even new Schrader valves leak. If you put an electronic leak detector over a brand new Schrader valve, a lot of times they'll register a leak. And I've had people online talk about the caps that go on top of a service valve, and they say they're just dust caps. They're only there to prevent dust from building up on. And I'm like, what are you talking about? So you're going to rely on a 5-cent item, 10-cent item that is the Schrader core to hold back all that refrigerant. You're going to rely on that? Are you serious? So
That's right.
I've always found, I've always found that I take the cap, I fill the cap with even a brand new core, fill the cap even with Nylog, tighten it, leak detector around it, nothing. Leak disappears, move on. Because it's not often a Schrader cap comes off, because you should not be putting gauges on the system every time you're there anyway. So that could stay on for years before it ever comes off and never leak. So you give me your beef with Schrader valves now.
Well, right on. So, I mean, the first point you brought up, the reason that they're used is because they're cheap. The Schrader cores are cheap. The Schrader, you can't really call the thing you put the Schrader core in the valve, but because the core is the valve. But the female component is also inexpensive. And besides their cost, they're used because it is an intuitive concept, right? And it works great for stuff like car tires, but you
Mm-hmm.
know, you don't want to drive around without your Schrader cap on your tires on your vehicle either. So yeah, it can be a frustrating thing. And another way you can find them on pressure tests, even with the cap on, is if you tie a small bag around them, you can still have, even with Nylog, I've seen it a couple times, you can have pressure leak through the Schrader core into the cap, out the cap, and into the bag. So, but very uncommon in my experience. Something about the cap that's important. Every time I pick up a Schrader cap to put on, I look inside of it to make sure that the rubber component is still there, because without that, they're not worth holding anything, right?
Oh, they don't hold nothing without the rubber. You're right.
So I'll credit you fully with about 2 years ago, the Nylog thing, Gary. So I was just having a bit of frustration with these because, the fact that they leak. And I actually tested it when I had like a few weeks to wait on my desk. I threw one on and tightened it up. I wrote the date on it, and I went to loosen it, and there is no resistance at all, right? Like people say that you're gonna get it stuck there forever. So yeah, but what I've been doing is I've been applying it to the thread on the outside of the Schrader and then putting the cap on. But good to hear your most recent, I guess, practice of filling the cap and installing it. So yeah.
Oh, that's not even recent. You know how that came up? People in Canada, people in the US wouldn't know this, but in Canada, federal buildings, they need to be leak if they have refrigerant systems, they have to be leak checked annually. So we had a bank, and it had a big chiller, and okay, we're going in for our annual leak check, and I'm going to all these Schrader cores with caps on, and some of them are leaking even with the caps on. So I went and changed all of the cores, all brand new caps, and filled every cap with Nylog on the threads. And every single year we went back, nothing, no leak. So it works, right? And I'm not trying to make a Nylog commercial out of this podcast, but it's just I found so many valuable things you can do with it, like flares, like putting it in caps, like on Schrader cores and stuff like that. But it's Schraders do leak, and we have to find a way to mitigate the leaking of a core, and a good solid cap with a rubber insert is going to mitigate it like 99.9% of the time.
That's it. And with that success rate, Gary, the last thing I'll add is that the past 3 years running a manufacturing and R&D plant that ships out products, that was always the final check to make sure that all the caps get nylogged and tightened accordingly to prevent leaks when the customer gets it. So absolutely.
So you were doing that in factory?
Yes. That became a practice after
Oh,
that tested it 2 years ago. So
very cool. Very cool. I didn't know that. So you spent 2 years R&Ding that, and then you applied it to your actual manufacturing process.
I would say the time 2 years ago was when I agreed with you on the practice of using it.
Okay.
And basically,
Okay.
we sent things out
Gotcha.
the door for 2 years ago following that as a final installation of caps, and had, success with that not leaking in the field for our clients. Yeah.
Awesome.
Yeah.
Cool, man. Well, I mean, we've covered a lot here, like leaking valves, 1.25 above your operating pressure. What else? Flares, flapper valves
Yeah.
that came out of nowhere.
That's right. Couple
All kinds
stories.
of things when it comes to pressure testing. So just keep in mind, guys, when you pressure test, especially with digital, you could have these weird changes because the sun's popping out, because it's equalizing. You have to pay attention to this and be cautious of it. And make sure you got a good solid pressure test before you pull a vacuum. And the other thing that you can do with your nitrogen before, just on the way out here, before you pull a vacuum, is you can let it all out, because there's going to be like air in the system when you pressurize. That's the other thing. It could change too, because there's a little bit of air in that system. But what you can do before you pressure test and after, I was going to say after, but what you can do before you pressure test is purge some nitrogen through that system. Just purge it slowly. Get all the air out that could cause issues with your rising and your dropping when the temperature is changing. Because the more air that's in there, the more rapidly your temperature swings will change your pressure in the system. So purge some nitrogen through for a bit, and then start to fill it up. And you might see a bit of a difference in when that sun pops out. You could. The other thing I was going to say is when you're done, you could sweep some through as well. Just one more time, just sweep it through before you pull a vacuum, just to make sure air, moisture, any other contaminants that are in there are kind of out before you start pulling a vacuum. Make your evacuation process a little bit more faster, a little bit more efficient.
Yeah. On that last point too, Gary, like testing that units that are identical side to side. Sometimes if you have a slow vacuum on the first unit and you do a sweep, like you said, on the next one, you'll see a way faster hold on for your vacuum. So for sure.
Cool.
Yeah.
Awesome. Julian, great conversation, buddy. I really appreciate the time today.
Yeah. Thanks, Gary. It's an honor to be on the podcast. So thank you for that.
Thank you.